Hey guys, I wanted to look at number 12 from tonight's homework. We're learning something new. It's attached to what you guys have done before, but we're trying to find out basically if they ask us to solve a system of linear equations, they're asking us to find out where two lines intersect. So if you have a line here and a line here, the solution to these two lines is right there where they intersect. And what we're doing here in this problem is just doing that without an actual graph. You could always graph it too, but that's kind of hard, especially when you're doing it by hand. So we're going to do it with the equations. We're going to take the picture and turn it into math and then solve it that way. So we have our first equation, 3x minus 2y equals 4, and our second one, 6x minus 2y equals negative 2. If we want to solve by elimination, it means we want to eliminate one of the variables. We want to get rid of it. Anytime you have the same coefficient, which is the number in front of the variable, that's the one we want to use because it's going to be the easiest to eliminate. We have a negative 2y and another negative 2y. If we added these two equations, we're either going to add or subtract them. Sometimes we may have to multiply first, but not yet. In this case, all we have to do is figure out whether to add or subtract these equations. What's negative 2 plus negative 2? Negative 2 plus negative 2 is negative 4, so that would be negative 4y. That doesn't help us. What's negative 2 minus negative 2? That would be the same as negative 2 plus 2, which would cancel out our y's. So I'm looking down here. What I'm going to do is subtract every term of the bottom equation from the top equation. Every term down here is going to be subtracted from the top thing. So what's 3x minus 6x? Well, that's negative 3x. This part is just the math that I did afterwards. And then negative 2y minus negative 2y is 0. So that cancels out. There's nothing else here. I could have written a 0, but I didn't. And then 4 minus negative 2 here is positive 6. So what we're left with after we do that elimination, we eliminated the y variable, and we get something that's pretty easy to solve. Negative 3x equals 6. If we divide each side by negative 3, we get x equals negative 2. Now, we have to find both the x and the y. Once we found one of the variables, it's pretty easy to solve for the other one. We plug it in to either of the equations, doesn't matter, one of the originals. I just picked the first one, so I'm using the first equation here. I plug in negative 2, because that's my x, and then I solve for y, just like you would in a normal equation. And here's my work down here. I ended up with y equals negative 5. Check to see if I'm correct. If not, and you catch me, email me or let me know somehow, and I will make sure that you are rewarded for watching closely. Anyway, I think this is correct. Our solution is negative 2, negative 5. I'm pretty sure that's the correct answer, but on a test, why not use a guarantee if we have it? To guarantee we're going to have the correct answer. If we get the answer we think is correct and plug it back into the other equation, number 2 here, because we saw number 1 here and we worked with that one. Now to check it, we want to use the other equation. So I'm going to plug negative 2 and negative 5 into the second equation here and see if it works. And when I work the math out, it does work. Guaranteed that this is going to be a correct solution to this system of linear equations.